This video is going over the test review of 2D and 3D figures for the test that will be on Wednesday. Remember that this test will be over perimeter and area, so our basic two-dimensional figures, in addition to our 3D figures. So everything from naming and classifying and identifying number of edges and vertices, all the way to volume and surface area that we've covered in the last couple of weeks. You will be able to use a formula chart, but you will not be able to use a calculator on your test. So make sure that you're comfortable with doing all of these calculations without the use of a calculator. All right, number one, find the area. So they're telling us straight up in our problem that we want to find the area within the white lines of the volleyball court shown to the right. So if you look at our rectangle here, they've given us our dimensions of our white line volleyball court. 59 times 29 will give us the area of this rectangle. So base times height, length times width, whatever you want to call it. When you multiply that out, you get 1,711 feet squared since it's area. Now remember, you won't be able to use a calculator on your test, so make sure you're comfortable getting these exact answers without the use of a calculator. Number two, coaches require all players to warm up by running the white lines twice around. Two key words there, twice and around. How far would a player travel? So they didn't tell us in this problem that we have to find perimeter, but using that clue word around, we're able to come to the conclusion that we need to find perimeter, and we need to find that perimeter twice because these students, these athletes, are having to run this twice. So 59 is my length on both sides. 29 is my width. So finding the perimeter for once, if they have to run around at once, I would add 29 plus 59 plus 29 plus 59 again. So when I add all those up, I get 176. So that's how far that they would run if they have to run it only once. But remember, these athletes are having to run around this court twice. So if I double that, that will give me how far they're having to run total. So 176 times 2 gives me a total distance of 352 feet. Make sure you're paying attention to keywords in word problems. A lot of times they'll spell out numbers that are important, so that you can try to trick you thinking that you're going to miss those keywords. Number three, Oakland Garden Center created a design plan for the Nelson family's rock garden. The shaded areas will hold flowers, and the rest of the garden will be rock. If each shaded area is a square, what is the area of the garden that will be rock? So this shaded part is where the flowers will go, and everything around that is going to be the rock garden. So let's just assume for just a minute that this entire garden, we need to find the area of it for rock. We know that we don't, but just for a few minutes, let's assume that we do. So to find the area of the whole entire rectangle, 5.5 times 8 gives me a total area of 44. But we know that these two square sections are not going to be rock, so I need to take those away from the total. We're told that they are squares. So multiplying 3.2 times 3.2 will give me the area of each of those flower sections. When you multiply that out, you get a total of 10.24 for each of the flower sections. So since I have two of those, 10.24 times 2 is 20.48. So I know that 20.48 of my 44 total is going to be flowers. So subtract that, and remember, when we add and subtract decimals, they have to be lined up. So 44.00 minus 20.48 will bring me to what's left over that's only going to be covered with rocks. And when you subtract that, you get 23.52 square feet because it is area. Number 4, the rectangle below has a width of 4.75 feet and a perimeter of p feet. So there's one of our key words, perimeter. Which of the following could be used to find the length of the rectangle? So our rectangle, we know we have a width on both sides of 4.75, length on bottom, length on top. So if I were going to find the perimeter, let's try to do this ourselves without looking at our answer choices. If I wanted to find the perimeter of this rectangle, I would do L plus 4.75 plus another L plus my other 4.75. So really, I have two L's and 4.75 plus 4.75. When I add that up, I get 9.50, or just 9.5. So my total perimeter is 2 lengths plus the 9.5. So look at your answer choices and determine which one of those is similar to what we've just found. C. The difference between C and D is the addition sign and the subtraction sign. So make sure you're paying attention to those small details. The shape of Valverde County in West Texas resembles a trapezoid. Use the picture below to answer numbers 5 and 6. Given the approximate measures, determine the square miles of the county. Square miles as a label looks like miles squared, and we know that exponent tells us that we need to find area. So make sure you understand those clue words. They didn't tell us in this problem directly to find area, but using those key words, that's the conclusion that we have to be able to draw. They've already told us about that it resembles the shape of a trapezoid. So using your formula chart, the area of a trapezoid is base 1 plus base 2 times the height of the trapezoid divided by 2. If you look at the trapezoid here in the picture, you'll see that your bases are actually these two pieces here. Because remember, your bases and your height have to form that 90-degree right angle. So if it helps you, turn your page around so that you can see that. So our bases are 33 plus 72 times my height of 60, and then divide by 2. When you do all that and apply that formula, you should get an answer of 3,150 miles squared, because it's area. The second part of this question says, if the county sheriff was to drive the county's border, how many miles would they expect to travel? So here, the border, our keyword, tells us that we need to find perimeter. So this sheriff is going to go all the way around 33, 60, 72, and 68.5. So adding all those together, you find that he drives a total of 233.5 miles. It's just distance. We haven't found area. It's just the distance that he's driving. So it's just miles, not miles squared. This review is misnumbered. It goes from 6 to 8, so there is no number 7. Number 8 says, the top side and front view of a solid figure made out of cubes are shown. Which solid figure is best represented by these views? So on my top, I need to see 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This one only has 3, so I can eliminate D. Now, from my side, I need to be able to see 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All of those work. And then for the front, I have 3, 2, 1, 2. 3, 2. This one goes to 2, not 1. That one won't work. 3, 2, 1, 2. That one works. This one starts out with just 2 on the edge, and I know that I need 3. So that one won't work either. So my final answer there is B. Number 9, use the figure to the right to answer each item below. Classify the 3D figure. This is a rectangular prism. Its base shape then is a rectangle. All prisms only have 2 bases, and this particular rectangular prism has 4 lateral faces, sides. Number of vertices would be 8. That's how many corners, how many points that I would have, like a box. So 8 vertices, 12 edges. Volume. So on a prism, we have the formula V equals big B, area of the base, times the height of the prism. My base here, it's area would be the 15.6 times 12. That's this piece down here. The height is the 9. So times 12, and then times the height of 9. So essentially like what you learned in 6th grade, length times width times height. 15 times 6 times 12 times 9 comes out to a total volume of 1,684.8. And because it's volume, it's millimeters cubed, cubic millimeters. Surface area. So wanting to find the area of all of the surfaces of this figure. Remember, on your test, you won't have this provided for you, but this is how you're going to want to set this up. So we want to find the area of the front and back pieces, the area of the top and bottom pieces, and the area of the left and the right pieces. So if it helps you, draw these lines for yourself so that you can keep yourself nice and organized. And at the very end, we can then add them all up to find our total surface area. So looking at this figure, it doesn't matter which piece you call the front or the sides. I'm going to call this piece right here the front. So it's this rectangle that I'm looking at. So 15.6 by 9 are its dimensions. So if I multiply 15.6 times 9, and I'm going to double that because I have a front and I have a back piece as well. I have two of those congruent rectangles. So when you multiply all of that out, you get 280.8. Now for my top and bottom. For my top and bottom, I have this rectangle, 15.6 by 12. So remember, if this side is 12, this side is 12. So 15.6 times 12, and then I'm going to double that because I have two congruent pieces. I have a top rectangle and a bottom. 15.6 times 12 times 2 comes out to 374.4. The last piece to solve for are the left and right sides. So my height of 9, my length of 12. So I have this rectangle here that's a 9 by 12. So 9 times 12 times 2, because I have two of those. 9 times 12 times 2 is 216. Now to find the total surface area, I'm going to add up all 6 of these pieces, my front and back, top, bottom, and left and right. So 280.8 plus 374.4 plus 216 comes out to 871.2, and this one is going to be millimeters squared. It's just area, squared millimeters. The next example is a triangular prism, and we're going to classify it, some of its characteristics, and then find its volume. So name a figure, triangular prism. So its base shape is a triangle. All prisms, again, have 2 bases. Lateral faces, it would have 3 rectangular faces, 6 vertices. These are your 6 corners. Remember your points on your figure. Edges would be 9. And the volume, so again, for prisms, volume is equal to big B, area of the base, times the height of the prism. Now remember, we just identified that the base shape here is a triangle. So I have a triangle as my base shape. So big B, area of the base, is area of this triangle. Remember, area of a triangle, base times height, divided by 2. So I'm going to do 3.4 times the height of that triangle, 5, divided by 2. That's going to give me big B, the area of the base. That comes out to 8.5. Now I need to multiply that by the height of the prism. This 8.6 here is the height of the prism. The way that this figure is laying, it makes it look like 8.6 is the length. But if I were to tip that prism over and stand it on its actual base, it would stand 8.6 centimeters tall. When you multiply out that area of the base times the height of that prism, you get a total volume of 73.1. So your total volume of the figure, 73.1 centimeters, and because it's volume to the third power, cubic centimeters. A block has a volume of 3,000 centimeters cubed. What is the height of the block? The block is not drawn to scale. So classify the 3D figure. Obviously, it's going to be a rectangular prism. It's not a cube because not all of its dimensions are the same. So this would be a rectangular prism. Now, they gave us volume of a prism. Well, we know volume of a prism on the formula chart, big B times H. So they gave us the volume, which is equal to 3,000. Big B is the area of the base. So here's my base down here, this rectangle. So its area is going to be the 300 times 10, or sorry, 30 times 10, which is 300. So that's my big B. And then times whatever the height is, that's the piece that we're solving for, equals 3,000. Like we learned earlier in the year when we're solving equations, to get the h by itself, because that's what I want to solve for, the opposite of multiplying by 300 is dividing by 300. Those will cancel each other out. Divide the right side by 300, you must divide the left side by 300. When you divide 3,000 by 300, you're left with 10, and on the right side, you're left with just the h. So the height is equal to 10 centimeters. The top view of a set of 4 equal-sized cans inside of a square box is shown below. Calculate the area of the square bottom of the box. Since it's a square, we know all sides are the same length, so 8 and 8. So the area of the box itself would be 8 times 8, which is 64 inches squared. Calculate the area of one can. So if all of these are equal in length, that means the diameter of both of these are the exact same. So if I split 8 in half, that gives me a diameter of 4 and a diameter of 4. The area of a circle, this area is equal to pi times the radius squared. So pi being 3.14. Here, if my diameter is 4, then my radius, the halfway point of that would be 2. So pi times the radius of 2 squared. 3.14, 2 squared has a value of 4, and when you multiply that out, you get 12.56. So each one of these circles has an area of 12.56. Calculate the shaded region. So knowing that each of them is 12.56, it's asking for what's left over for just the area of the shaded region. Well, if we know all of it together was 64, I can subtract the area of the circles. So multiply the 12.56 times 4, because I know there's 4 of those there. So those 4 cans are taking up an area of 50.24. So if I subtract that from my 64, I'm left with the space that's not being taken up by the cans. So 64 minus 50.24. Remember, when you add and subtract decimals, you have to line them up, which is why I did 64.00. And there you get an answer of 13.76. And that would be squared inches. And that's the answer to part 3. Last question. Given the net of a cylinder, determine the volume. So on your formula chart, the volume of a cylinder is the same as a prism, area of the base times the height of the cylinder. So the area of the base, the cylinder has a circular base. So kind of envision like your soup can has a circle base. So the area of a circle is pi times the radius squared. My diameter is 6, which means my radius is 3. They just gave it to you in 2 different pieces. So my pi, 3.14, times the radius, 3 squared. 3 squared is the value of 9. 3.14 times 9 comes out to 28.26. So my big B is 28.26 times the height of my cylinder. If I were to fold this top circle down, the bottom circle up, and wrap my rectangle around, that would be my face of my cylinder. Think of like your label on your soup can. When you multiply 28.26 times 2, you get a total volume of 56.52 cubic, because it's volume, inches.